Day 50, Honors Physics, Conservation of Momentum, problem number 32. Once again, this one also has elements of conservation of energy. This is a fairly classic experiment where you shoot a bullet straight up into a block of wood and the wood rises to a certain height, and you can use this to figure out what they call the muzzle velocity of the bullet. In other words, how fast is that bullet coming out of that gun? All right, so this problem has to be sort of done backwards. So over here in part number 1, I've labeled over here, we're going to start with conservation of energy, kind of backwards. We'll take a look at the GPE of the block and the bullet as it's 3 meters high, and that came from the kinetic energy of the block and the bullet after it was quote-unquote launched. In other words, you fire the gun, the bullet embeds in the block, and then the block has a kinetic energy. As it rises, it turns into GPE. We're assuming no loss on the way up, so conservation of energy. So we set the GPE at the top equal to the launch kinetic energy of the block and the bullet as it comes off the gun. Once again, it's mgh equals 1/2 mv squared. Because it's the same mass on both sides of the equation, that does cancel out. So I'm not going to use it this time. In past problems, I've still used it, but you don't need to use that. And you just calculate the velocity of the block and the bullet as they are launched off of the gun. All right, then you go over to conservation of momentum, and we're going to do that sort of backwards. In other words, we're going to look at the after the collision compared to before the collision. So after the collision, so to speak, when the bullet is embedded in the block, there's a momentum. I'm calling it P total. The T stands for total here. The total momentum of the block and the bullet together is the mass of the block and bullet, which is 2.025, assuming the block is good to 4 sig figs, which is a slight violation there. We'll round this back off. We're not going to stick with 4 sig figs. Times the velocity of the block and bullet, as we found out in part 1. So the total momentum is 15.5 kilograms meters per second. I probably prefer you go down to 16 kilograms meters per second. Go back down to 2 sig figs here. But I'll let you go to 3 in your answers. All right, so we have that amount of momentum after the collision, which means before the collision, which was only the bullet, just before it enters the block, which is what we're most interested in, is the bullet only must have that same momentum. So this goes into the momentum of the bullet. So the B there stands for bullet, the momentum of the bullet. The bullet has the total system momentum before it embeds into the block. That's why I plugged the 15.5 into there for the momentum of the bullet. And we know the mass of the bullet, 0.025, and then you divide and you get the velocity, the launch velocity, the muzzle velocity of the bullet, 620 meters per second, which is quite fast. That's quite a bit faster than the speed of sound. Speed of sound is like 344 meters per second in standard air temperature. So that's not quite twice the speed of sound. Speed of sound, 344 meters per second, is just over 700 miles per hour. So this is up here. This is over.